Awesome. So lesson 5, this one is going to be parts of a similar triangle. Similar triangles. I'll let you write some notes down and then I will discuss it. All right, so by the end of the lesson, you guys will be able to use proportional relationships. When we have two triangles corresponding to angle bisectors, their altitudes, and then the medians of similar triangles. So we'll have two triangles. And then the other part that we'll do, is that you guys will be able to use this theorem, the triangle bisector theorem, to compare one triangle to itself. Okay, we're gonna have a bisector that'll go through it, so we'll only have one triangle, but we will be able to compare that to itself. For this lesson, I'm going to talk a lot about making sure that I line up the top and which numbers I'll use for the top of my proportions, which one I'll use for the bottom of my proportions. Because as I went through the quizzes, that was the thing that people struggled with the most, was being consistent on which one you're going to use kind of for your top number, which one you'd use for your bottom number. Okay, so I've got 3 separate theorems that we'll talk about. I'll zoom out a little bit. Mainly, I want to draw the pictures and kind of highlight what we're discussing. All right, so the first one that I'm going to discuss is this similar triangle, is that if we have a line that's going to go straight through the altitude, and it comes down to a perfect 90-degree angle on the bottom, okay, where it has exactly 90 degrees on the bottom, I can compare, this angle, this AD, and that FJ, to one of these other sides. Up until this point, we had compared just the outsides of the triangles to the outsides of the triangles. Now we're getting one extra line that's going to cut down through the center of the triangle. And if it follows one of 3 specific rules, we can also use that line to help find proportions. So again, if I have a 90-degree angle to the vertex, okay, that'll let me know. Again, these sides are still going to be able to be used. These bottom ones will be able to be used. But if we have 90 degrees to the vertex, so from the bottom side to the vertex opposite of it, I can use that to find proportions. Good on that one. My next rule is that if I have an angle bisector, meaning the angle on the top is perfectly cut in half, don't worry about the bottom stuff, but if the angle is perfectly cut in half, I can compare that center post to that side, or I can compare that center post to this side, or I could compare that center post to this side. And the very last rule that I'm going to have, that we'll talk, excuse me, is if I can perfectly bisect this line of the triangle, so I can cut this bottom line perfectly in half, then it's going to be able to be used to make those comparisons again. So if I have a perfect line bisector, I can compare this line to this one, or to this one, or to this one.
Can you pull back up?
Yeah. Which one do you need? Sorry.
The second one. That one, yeah.
Yep, sorry, I went too fast.
Okay.
Anybody need more time on this one? Anybody need more time on this one? Okay, so I wrote it on the board here, but I'm going to write it again just one more time just to kind of verify it. The 3 special rules that we have to just verify if they work. Is it 90 degrees to the vertex? So from the bottom line, is it 90 degrees to the vertex? Is it an angle bisector? Bless you. Or is it a line bisector? If it is either of these 3, then we can use that middle line, that middle post, to compare it to other triangles using the proportions. Okay? I'm going to leave it on the board over here so I can kind of point it out. All right, so number 1, excuse me, I will do this one, and by myself. Next one, I'm going to have you guys help me, and then the third one, you guys are going to do on your own. So if you'd like to write the triangle down, kind of the shapes, and then I will discuss it. All right, so looking at these shapes, I can see that they have kind of the matching angles. So this has a matching angle here. These ones have a matching angle here. So I know that the triangles are going to be similar because my angles are matching up. And now, if my triangles are similar using that, can I go with one of those rules that proves that these are the same? Or how about this? It is. Which rule am I going to use to show that they're the same? That I can use the middle post. 90 degrees to vertex, perfect. You got this little 90 degree symbol, this square. So I know that they're going to be 90 degrees to vertex. So I'm going to just do an extra step here. This triangle over here, this KLM, I'm going to make sure that one is going to be my top for my fractions. Because again, that's kind of the area that I saw people were struggling with. This triangle over here, when I set up my proportions, I'm going to make sure that one's my bottom. So again, this will be the top, this will be the bottom. So looking at my first triangle, I've got 16, which is the middle one, over x. Again, both the middle ones. Now I'll compare the sides. Again, the 20 is from my big triangle, so I'm going to put it on top. And then 15 will be for my small triangle, so I'll put that one on the bottom. Yes, please. Thank you, sir. And then as soon as you guys get it set up here and do the proportionality parts, the cross products, you guys can crush this stuff. Okay. Also, we are not having homework today. It's just going to be notes today. So So I got the cross product for that stuff. It turns into 20x equals, and then 16 times 15. Just did this one a little bit ago. Equals 240. Divide both sides by 20. X equals 12. All right. The one other kind of quick little rule that I'm going to give, not like a super hard rule, but just a way to verify if it looks correct. If it looks somewhat correct. I can see in this one, it's 16 to 20. This one is smaller than this number, right? So this is a bigger number, this is a smaller number. Just verifying, this number should be smaller than this one. It is, it's a 12, it's smaller. It looks like it's correct. If that number is super big, then I can kind of know right away, maybe I should double check that problem and rework it, just to verify. All right, on to my example number 2. This one I'll have you guys help talk me through it. I'll zoom in so you guys can write it down if you'd like to. All right, with those triangles, which rule does it follow that lets me know that I can use that middle one?
Line bisector.
Perfect. I got the line bisector, meaning this line over here is bisected, it's cut perfectly in half. This one is bisected, cut perfectly in half. Okay, because of that, I know I can use the middle line to compare some things to.
If
Okay.
it's not any of them, can you just say like none?
You just won't use the middle. Yeah. You would be able to use like the outside angles or the outside sides, but yeah, you could not use the middle of it. All right, so I'm going to do the same thing. I'm going to say this one will be my top number. This triangle will be my bottom number. Just being consistent here. So if I use the diagonal that cuts through it, I should have 13.5 over 9 equals x over 3. Now I can cross multiply. I get 9x equals, 40.5. Divide both sides by 9. I get x equals, should be 4.5. Yep, 4.5. How you feeling? Thumbs up, thumbs down? I like it. All right, the next example I want you guys to do all on your own. I'll zoom in as best I can so you can see the whole thing. we're gonna set them over each other. So that will be perfect. And then whatever the number is, or whatever the either number or symbol is from this side, should be this guy right here. Yep. What's on the bottom one? On this triangle.
Oh, that's.
The 5.
Oh, I thought it was the A. Oh, that's.
Perfect, you're good. Fantastic. Perfect. Yep, that's the one. All right, I'm gonna write these ones down. I like what I see. So same thing, I'm gonna say this is me, my top, this will be my bottom. So when I set it up, it should be 12 over 8 equals x over 5. You guys did the cross multiplication perfectly. You did 8x equals 60. Divide both by 8. Your final answer, x equaled 7.5. Perfect. You guys doing great. Feeling good on that stuff?
Yeah.
Super. So here's going to be my last rule that I'll have with you guys. And this is only when we have just one specific triangle. I'm not comparing it to two separate triangles. I'm just comparing it to one. So let me draw the picture so I can show you what I'm really asking or pointing out. If I have a triangle and it has an angle bisector, meaning the line that's going straight to the center of it is exactly the same on both sides, I can compare this side and this side will be similar. And then this side and this side will be similar. Okay, if I have an angle bisector in one specific triangle, these two will have the same proportion as these two. Okay? So it'd be like this one over this one equals this one over this one. Okay, that's the biggest part about this last one. It has to be an angle bisector, so they need to have the exact same similar arcs here to show that they're the same angle. But if they do that, it will follow through the exact same rule. All right? So zooming in on this shape here, I'll let you write it. I think this is the last one we're going to do today as well. All right, so I've got this triangle here. Same way, I'm going to say this will be my, this will be my top, this will be my bottom triangle. Again, I'm just writing this down so I can stay consistent because this is the area where people tend to make little simple mistakes. So I've got x over 13 equals 4 over 6. Again, I can compare the top two numbers, bottom two, and now I'm going to be able to cross multiply. I've got 6x equals 4 times 13. That's going to be 52. Give me 1 second. And then, sorry, my calculator's not like me right now. And then what I'm going to do is I'm going to divide both sides by 6. My final answer, jeepers creepers, is going to be 8.6 repeating. Again, I can set these same sides equal to each other as long as there's an angle bisector. And then I can find that proportions. Questions on this stuff? Okay, Monday. Yeah, I did that one. Monday, we will finish up, or sorry, for you guys, Tuesday. Tuesday, we'll finish up the lesson. We will have an assignment on Tuesday, and we'll probably get going on to a little bit of the next lesson possibly. Okay? Yes, ma'am.